It is 2 a.m., 40,000 orders. Stuck. Hi everyone, my name is Raja Jamwal. Today we are talking about queues, locks, and rate limits all using the Postgres. You run checkout for an online store, buy now in queues 3 jobs, charge the card, send the receipt, and update the inventory. Those jobs sit in Redis, fast, in memory, and living entirely in the RAM. Redis restarts for a routine maintenance, and the RAM empties. The queue empties with it. The card was charged, the receipt never sent, the stock count never moved. So you move the queue into the Postgres, one table called jobs with a status column. Two workers pull it at the same exact instant, running the exact same select statement. Both read the same row. Both think they are the one who gets to process it. Both charge the same card, and you have just built a double charge machine. The fix is one clause. For update, skip locked. Worker 1 opens a transaction, selects the oldest row, and locks it for update. Worker 2 runs the same query, but skip locked means skip that row and grab the next one. Two workers, two different jobs, zero collisions, zero blocking. Here is the whole worker. In pseudocode, you could run against any Postgres database. Begin a transaction, grab one job, logged, skip logged, mark it running, same transaction right there. Commit that claim immediately. The job is yours now, durably, even if this proceeds to die mid-task. Do the work on success, mark it done. On failure, bump the retry count and put it back in the queue. Pooling every second works, but that is a full second of latency times every worker times every empty pool. Postgres has a built-in publish and subscribe system, the listen and the notify. A trigger fires notify new job the instant a row is inserted. Every idle worker wakes up immediately. That is Redis PubSub's job, done by the same database that is already holding your queue. Some locks do not protect a row. They protect an action. Charging a card is a call to an external API, not a database write. PG advisory log takes a plain number as a key. No table, no row, a log that lives only in Postgres memory. Server 1 calls PG try advisory log, the hash of the order 4471. It gets the log and calls the payment API. Server 2 tries the exact same key, locked, it backs off. The card only gets charged once. One more job Redis usually does is rate limiting your calls to the payment gateway. One row per time window. Insert or on conflict, increment the count and return the new value. That is one atomic statement. Increment and then read happen together. So two workers cannot both slip through at 99. Over the limit, reject or delay. Same guarantee as Redis increment plus expire, no second system required. This is not a thought experiment. Rails 8 actually ships exactly this as its default job backend, the solid queue. Skipped logged for claiming jobs, advisory logs for concurrency limits and scheduling, Postgres, and nothing else. It runs in production behind thousands of apps that used to need a separate Redis box just for background jobs. This is not a Kafka replacement. It won't stream millions of events a second across a cluster. A busy job table still needs to be vacuumed and index needs to be upkept, or the dead rows pile up under all that update traffic. But for the volume most teams actually run, few hundreds, right? Low thousands of jobs a second. Postgres carries it with room to spare. Back to that 2 a.m. page. Same checkout, same three jobs, charge, email, and the inventory. This time, the queue is a table. It survives a restart because it was never just sitting in the RAM. One database, one backup, one thing to monitor at 2 a.m. And this time, it is still there in the morning. That is all for today's video on Postgres as your queue, as your log manager, and the rate limiter. And I'll see you in the next one.